Hello class, welcome to another identity with comma notations. Okay, now we have to prove, so PT means prove that divergence of curl A transpose equal to 0. Okay, now what is our A? Our A is a second order tensor. Second order tensor. Okay, what is curl of that A? Is also a second order tensor. Also a second order tensor, because applying curl, the order will not change. Order remains the same. If A is second order tensor, curl A is also a second order tensor. Then what is divergence of this? Or rather, I want transpose. So what is transpose of this? The next step, the transpose. So curl A whole transpose. If curl A is a second order tensor, curl A transpose is also a second order tensor. Is also second order tensor. Right. Now, divergence of this. Divergence of curl A whole transpose. So, divergence means it is actually the order will get reduced by 1. Curl of A whole transpose is second order tensor, right? So, divergence of this is a first order tensor. Is a first order tensor, and first order tensor is nothing but a vector. So, this is a vector. So, how many free suffixes? Only one free suffix. Okay. Right. What is LHS? What we have to prove? I am taking the LHS of that. LHS is divergence curl A whole transpose, and in components form. So, this is a vector, no? One free suffix, right? And remember, what is RHS we have to get? We have to get it is 0, right? So, now, so in the next step, we'll write what is curl A and we'll use divergence. Divergence means it is differentiation, right? So, that is equal to, next step, that is equal to curl A whole transpose is a second order tensor, right? So, components are ij, two suffixes ij, right? Divergence denotes differentiation, right? So, comma, comma, and I want I, only one free suffix. So, here the next one with respect to j I have to do. So, j is dummy, and finally I get this one free suffix I, right? Now, that is equal to, now I'll remove the transpose. So, curl A, I'm removing the transpose. That means what? What are we doing? We are interchanging rows and columns. That means what? We are interchanging the suffixes I and J. So first J, then I, comma J, comma J, because we have removed the transpose. So removing transpose means what? Interchanging of rows and columns. So interchange I and J. So J, I, comma J as it is. Now we'll use curl. We'll use curl definition. That's curl there. Okay. Now we have to use the definition of curl A. Curl A, what components? I want JI components. So that is in terms of epsilon now, right? So epsilon. So first you have here J, right? So J. Other two suffixes could be anything. We'll take as M and N. Then I have to take the components of the tensor A, right? So small a, right? The next suffix there is I, so it is I. right? And here we have taken mn, so I should have the reverse there. So it is n comma m. This is the components of curl A. What components? Ji components, comma j as it is, comma j as it is. Okay, so now that is equal to epsilon jmn, epsilon jmn a in comma comma mj, mj, because after comma differentiation with respect to m and again differentiation with respect to j, so I'm just combining those two, putting as comma mj, right? Okay, so now we'll call this as equation 1. We'll call this as equation 1. What is our LHS? LHS is nothing but divergence of, we have divergence of curl A whole transpose I component. Is this, we'll call this as equation 1. Right? Now this is happening for all m, for all j, for all n. What we do is, we have j dummy, m is also dummy, n is also dummy. Now the next step what we do is, we'll interchange or we'll just replace or interchange m and j. We'll interchange m and j because m, j, n, they're all dummy suffixes. So in the place of them, I can have any one. Now here what I'm going to do is, I'm interchanging in equation 1, I'm interchanging m and j. So when we interchange m and j, so wherever m is there, I have to put j, and wherever j is there, I have to put m. So that is equal to, so let me take that. So epsilon jmn ain comma mj. So I'm interchanging. So when I interchange the dummy suffixes, I can have dummy suffixes, any suffixes, no, right? So no change. So these two are equal. So tell me no now. So epsilon, in the place of j, I'm putting m, and in the place of m, I'm putting j. N as it is, a, I also as it is, n also as it is, comma. So in the place of m, we are putting j, and in the place of j, we are putting m, right? That is in the equation 1. So interchange these two in equation 1, right? And these two are same. Fine. Now in the next step, so mjn, look at the suffixes mjn. So let me take in what order I'm writing the order now. So mjn. So if mjn is cyclic or clockwise, okay. Now what is this? Epsilon jmn. Epsilon jmn. So what is epsilon jmn now? So j, here is j, next is m, then is n. So what is the order now? So first j, m, n. This is the opposite. So opposite directions, no. So the minus sign should come. Fine. So epsilon mjn is equal to minus epsilon jmn. The remaining as it is. So a, in, comma, jn. Right. Now that is equal to minus epsilon jmn, okay, a, in as it is, comma, after comma we have j and m in the previous step, that is here, right? That is first differentiation with respect to j, then differentiation with respect to m. Now these two, I can change the order. First I can do differentiation with respect to m, and then I can do differentiation with j. Both are same, no? Right? So I've just interchanged jm to mj because it is after comma. Right? Now, look at LHS and RHS of this. So what is LHS? LHS is this and RHS is this. Is it not the same? See, epsilon jmn ain comma mj is equal to minus epsilon jmn ain comma mj. Right? So we'll take all these two on one side. So we'll shift this that side. So same terms, no, they get added up. This minus will become plus when it comes this side. So twice epsilon jmn ain comma mj is 0. That implies what? That implies epsilon jmn ain comma mj is 0. Right? So what is equation 1? Equation 1 is telling me what? Equation 1 is what? Equation 1 is this epsilon jmn ain comma mj is equal to what? Is equal to divergence curl A transpose I component, right? So this implies in the next step by equation 1, so by 1, using 1, so we get divergence curl A whole transpose I component is 0 because 1 implies this is equal to this. Since this is 0 here, right, this is also 0. Right. So therefore, whenever the components are 0, the corresponding vector is also 0. A whole transpose is 0. Hence the identity. And very nice proof. Okay guys,